In this video, we're going to take a look at finding the determinant of 2x2 matrices. Now, for finding the determinant of 2x2 matrices, the method and the process is quite nice and straightforward. However, in this video I'm only going to be showing the method and the working. I'm not going to go into detail as to why the determinant is important, but I will show that in more detail when we take a look at linear transformations. So if you want more information about that, be sure to check out the videos on linear transformations. So, to start with, we're looking to find the determinant of these two examples here. So we've got the matrix A and we've got the matrix C. Okay, so let's start with the matrix A. So to find the determinant here of this matrix, all I simply do is I find the product of the main diagonal. So we're going to do minus 4 times 2. So minus 4 times 2. And then we subtract the product of the other diagonal. So we find the product of the other diagonal and we subtract it from this product. So A times minus 2. And all I need to do now is evaluate each one of these individually. So minus 4 times 2, that would give me minus 8. Minus, so 8 times minus 2 would be minus 16, but minus 16 is just the same as plus 16. So we get minus 8 plus 16, which just gives me 8 there. Okay, so let you can see the method, the working, nothing too challenging. It's literally just a bit of multiplication and subtraction. Okay, so that's the determinant of A. For the matrix C here, now what we've got here is a matrix which involves algebraic elements. And this can come up, and what this essentially does is it eliminates the ability to use your calculator, and this is quite common by exam boards. So the method and the working is the exact same though. So what I do is I find the product of this main diagonal here, and then we find the product of the other diagonal, and we subtract the other diagonal from the main diagonal. So for det C here, like I said, start by finding the product of the main diagonal. So that's going to be A lots of A plus 4. And then we subtract the product of the other diagonal. So minus 4 times 2 there. And then simplifying as we go along here. So I've got A times A, just expanding this bracket here. I get A squared. A times 4 gives me 4A. So I get plus 4A there. And then we do minus 4 times 2. So 4 times 2 is 8. So we get minus 8 there. And notice that's exactly what we're asked to show here. So det C is equal to A squared plus 4A minus 8. And we've got the exact same there. Now before you have a go at a couple of practice questions, there's just one thing we need to point out here. So if you get a determinant that's equal to 0, so let's just say we're working with a matrix A, and let's say we get det A is equal to 0. Then this is special because what this is what we call a singular matrix. So this is a singular matrix. Okay, and the reason why this is special is because for a singular matrix, the inverse does not exist. And you'll see that in more detail when we take a look at finding the inverse of a 2x2 matrix. Okay, if the determinant of the matrix, say det A, is not equal to 0, so it's not equal to 0, then we just say this is a non-singular matrix. Okay, just so you're aware of that. And just one other quick point to make here. When you're working with determinants, sometimes they might use different notation. So instead of saying find det A, they might put find A, but it's between these two bars here. It just means the same thing. This is the determinant of A. Okay, so just a little bit of different notation there. You'll see this in more detail when we take a look at finding the determinant of a 3x3 matrix. So I do use that notation myself, so just be aware of that. So we've worked through a couple of examples together. Now it's your turn to have a go at a couple of practice questions. So like always, pause the video now, have a quick go, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with these two problems. Let's take a look at what you should have got now. So again, we've just got matrix A here, 1, 0, 0, 4. And for this one, we're asked to show that det A is equal to 4. So we already know what we should get here. So hopefully it should be quite nice and straightforward. Just the same method, same working that we've done for the previous two examples. We find the product of the main diagonal. So det A here, we do 1 times by 4. And then we subtract the product of the other diagonal, which is just going to be 0 times 0 in this case. We don't really have to write this down. It will obviously just be 0, but just so we can see the actual method in full. 1 times by 4 is 4, minus 0, we just get 4. So there we go. So det A is equal to 4 as required there. Okay, so nice and easy. For the next one here, we've got the matrix B, and this is defined as 5, 3, minus 1, and 2, and we're asked to find det B. So again, we should hopefully be getting quite good at this by now. So det B. All we want to do here then is find this product, so 5 times by 2. 5 times by 2, and then we subtract this product here, so 3 times by minus 1. So 5 times by 2 is 10. 3 times minus 1 is minus 3, so minus 3 is the same as plus 3. So we get 10 plus 3, giving us 13 there for the determinant of B. So before you move on to take a look at finding the determinant of 3 by 3 matrices, make sure you are confident with this. You have to find the determinant of a 2 by 2 matrix for a 3 by 3 matrix as well, and you'll see that in the next video, so make sure this is a skill that you're confident with. So that brings us to the end of this video. In the next video, we're going to take a look at finding the determinant of 3 by 3 matrices.